All right, this is a reconstitution example. So with reconstitution medications, what we want to pay attention to is the fact that there is certain information that is presented that looks very similar to your standard injectables and oral suspension type questions, but there's a little bit of nuance to solving this, and so I'm going to help you navigate it. So you'll see that we have an order for the Kefsol 325 milligrams intramuscular every 6 hours. Now, if you're on a test where it says how much will the patient receive in one dose and it's intramuscular, you know right off the bat that you're giving them milliliters. Typically, you would look at your label and you would say, oh, okay, I'm looking for either milligrams per milliliter, grams per milliliter, maybe even per teaspoon. But this says 1 gram, and that's all it says. It doesn't say anything about milliliters. So that's your key that you're dealing with what's called a reconstitution type of question. So what we're going to do is we're going to look at our side label. So the rule is with reconstitutions, you have to look at the side label. Okay. You have to look at what's going on up in here to look for your information. Now, the first thing it says it's for intramuscular use. It tells you to add 2.5 milliliters sterile water, and then to shake well. So that adding a 250 or 2.5 milliliters of sterile water is what the pharmacy would do, or maybe you would do in a certain situation. You're adding water to the powder, but you do not need that for your calculation. So as far as the math is concerned. Then it tells you after you add the 2.5 milliliters, it will give you an approximate volume of 3 milliliters. Again, I don't really need to know that unless I don't have any other information in order to calculate a grams per milliliter or milligrams per milliliter. What I'm looking for is this right here, where it says 330 milligrams per milliliter. That's the concentration that you would use for solving your this problem. Okay, that's your available. Okay. And then it tells you some other information about intravenous use. So if this were an IV question, you might want to look at some of these things, but it looks like for at least the questions that I've seen on this, it's more the intramuscular version. And then the other thing is, and something to always pay attention to is, does this fit within the normal adult range? 250 milligrams, 1 gram every 6 to 8 hours. We're at 325 milligrams. So we're in the safe zone as far as that's concerned. So setting this up, there's 2 ways you can do this. You can do this dimensional analysis, or you can do this using ordered over half. So I'm going to do order over half first. So I'm going to take what my order was, the 325 milligrams. I'm going to put that over my available, which is the 330 milligrams. And I'm going to multiply by my quantity, which is 1 milliliter. I'm going to plug that into my calculator. $325 divided by 330 gives me 0.98484848. So if you, depending on your rounding rules and more importantly, the type of syringe you're dealing with, you would round this to 0.98. There's a 484848, but since this number is 4, that number is less than 5, and so we're not going to round that up. So your answer would be 0.98 milliliters. Now, if you have to mark a syringe, like this question says to mark a syringe, you may not be able to get to 0.98. So you can see that we have half a milliliter, so 0.5, then 0.6, 0.7, 0.8, 0.9, and then 1. So if it's like that, my recommendation would be to go ahead and indicate it as 1 milliliter, because that would be the closest mark, and you want to mark it on the actual syringe. Okay. But your answer technically would still be the 0.98 for the order given this. Okay. If you're doing this dimensional analysis, you would pretty much set it up the same way, except you would take your 325 milligrams over 1. Then you would set this next to your conversion. You don't want milligrams. You do want milliliters. 1 milliliter, 330 milligrams. You know you did it right because you can cross these out and you're going to get the same answer, the 0.98 milliliters. If you want to test yourself on this, you can use this same label, the 330 milligrams per milliliter, which you probably already know how to do. The trick to this with reconstitution is just knowing where to find this information. But you can just change this number, any number between 250 and 1 gram every 6 hours. That's what you can use. So you can try 750 milligrams if you want. You can try 800 milligrams. I mean, try a couple different things, and then you basically have a couple different orders, and then you'll have a variety of different answers to put on to your equation. Anyways, I hope that was helpful.